Good morning, everyone. My report is all about parallel operation with an equal voltage ratio. Before we go to this certain topic, let us first discuss the consideration or the requirement needed to undergo the parallel operation. First, voltage rating of both primaries and secondaries must be identical. What does it mean? It means that voltage rating of primary and secondary transformer must be the same. Why? Because if there's a small difference in primary and secondary voltage rating, it may cause a high circulating current, and the high circulating current may also cause unnecessary extra I squared R loss or extra power loss. We need to consider that it should have a same number of turns or turn ratio. Here, if the primary and secondary has a differ number of turns ratio in the voltage rating, current will have a extra circulation if the number of turns are not the same. That's why power loss must be will be occur. And number two, the transformer must be properly connected with regards to polarity. Yan. We all know that incorrect polarities will produce a short circuit. And we also know what happened if in the circuit if there's a short circuit happened. Number 3, the ratio of equivalent resistance to the reactance of all transformer should be the same. Why? If there's a difference between two transformer in parallel, it results a different phase angle. If there's a difference between phase angle, it also results that the one transformer will be working with a high power factor and the other one has a lower power factor. What will be the effect of the power factor? It may affect our apparent power. Next, the advantages of parallel operation of transformer. Number 1, increase the reliability. Yan. We can depend to this transformer. Number 2, maximize electrical power system availability. Next is voltage ratio. Voltage ratio is defined as the ratio of the primary voltage of transformers to the secondary voltage. In transformers with these small transformation ratios, the turns is usually equal to the voltage ratio. Like stated in the requirements, the voltage rating must be the same in transformer 1 and transformer 2, and also its number of turns, so that the voltage rating and the number of turns has a relationship which is directly proportional. And variables to remember before we go to the solving in this topic. Z sub 1 is equivalent impedance of transformer 1 prepared to the secondary. Z sub 2 is the equivalent impedance of transformer 2 repaired to the secondary. I sub 1 is the current delivered by transformer 1. I sub 2 is the current delivered by transformer 2. I sub T is the total current or current drawn by load. B sub 2 is the load voltage or terminal voltage. G sub 2 is the voltage induced in the secondary winding. A sub 1 is the voltage ratio of transformer 1, and A sub 2 is the voltage ratio of transformer 2. Take note, if the variable of the given has a prime, it means that it is from transformer 1. For example, there's a given problem and the variables has a prime in it, and it means that all that given is come from transformer 1, and the rest, whatever subscript it has, for example, z prime, and the other one is z sub 1, so the z prime is the given from transformer 1, and the z sub 1 is from the transformer 2. And lastly, load operation for transformer with an equal voltage ratio. This is the formula. Yeah, for transformer 1, the above formula. And for transformer 2, we need to get the value for the transformer 2. It's the delivered current, the below formula. And if there's other missing or other variable missing, or what we have looking for, we just need to derive in this formula. That's all, and thank you.